We are group 2. We are gonna explain the tutorial number 8, which is based on the throttling valve. So this is the schematic diagram of the throttling valve. Next, Junji will explain the function of the throttling valve.
Thank you, MASITAH. This is the function of throttling valve, where it is used in decreasing volume flow rate of flow to cause a pressure drop at the exit. Throttling valves are a type of valve that can be used as start-stop to regulate the flow of fluid through the rotordynamic pump. Note that when a fluid flows through the throttling valve, there is no enthalpy change and no work done. It is an adiabatic system and irreversible process. Next, I will pass to HAIQAL.
Thank you, Jason. Okay. For the next part is application of the throttle valve. We found that two throttle valve that apply in the daily life. The first one is gasoline combustion engine. Throttle valve for regulating the supply of a fluid as a steam to an engine, especially the valve controlling the volume of vaporized fuel delivered the cylinder of an internal combustion engine. Air flows down through the throat of the carburetor, past the throttle valve and into the intake manifold. The throat is formed by the reduced diameter and acceleration of the air through the smaller passage causes a decrease in pressure related to the amount of air flowing. This decrease in throat pressure results in fuel flow from the jet into the airstream. Okay, next part.
A throttle valve can also be used in an air conditioner. The main function of a throttle valve is to reduce the pressure of the refrigerant. The refrigerant leaving the condenser is at high pressure. The pressure of the refrigerant has to be reduced so that it can vaporize at the required temperature in the evaporator. The small opening, or it can be also called the orifice in the throttling valve, reduces the pressure of the refrigerant to the level such that vaporization of the refrigerant occurs. The refrigerant leaving the throttling valve enters the evaporator at low pressure, low temperature, and partially liquid and vapor state. Next.
We are assigned to do the question number 8. For the assumption of this question is it is steady flow, so there is no rate of change of energy. The kinetic energy and the potential energy is 0. It is a adiabatic process, so the Q is negligible and there is no work done. Next.
For the calculations, we start with energy flow in minus energy flow out equals to the change in energy of the system. Since this is a steady flow control volume process, we know that the change in energy of the system is equals to 0, giving us energy in equals energy out. Then we can expand the energy term into Q, heat transfer, W, work done, plus the mass flow rate multiplied by the specific enthalpy plus kinetic energy plus potential energy. Then from our assumptions, KE, delta PE, Q in, Q out, W in and W out are all equals to 0, leaving us with negative M multiplied by delta H is equals to 0. And then we can expand the delta H and we are left with H1 is equals to H2.
Since the question already provided us the pressure values, we can use table A12 to find the other information. So for 700 kPa, T1 is 26.69 Celsius, H1, which is the saturated liquid enthalpy, is 88.82 kilojoule per kg, and H2 is the same as H1 as derived from above. Then for 160 kPa, we can find the HF and HG. From all those values, HF is smaller than H2, and H2 is smaller than HG, so we know that it is a mixture. Now that we have all the other informations and values, we can continue with the calculation. So with this enthalpy equation here, we can find the X value, then substitute the X into the specific volume equation to obtain the final specific volume of the refrigerant. Lastly, T1 minus T2 and you'll get the temperature drop, which is 42.29 Celsius. That is all from us. Thank you.